Doing well, doing well.
Hey,
Hey
Wayne.
Matt,
Hey, Matt.
How's it going, you guys?
Doing
good,
well.
good.
We're live with our new webinar system. This is exciting.
I know Wayne sounds very, very good today.
Professional Mike.
There we go. Podcasting booth. All right. Let's just give everybody a couple minutes before we get started.
All
All
right.
right.
Very excited for this hour together. Never been so
Yeah.
excited for reliable payments.
I know. It's
Actually,
not it's not like it's something that we talk about day in, day out, right?
yeah, I've been excited about reliable payments for years now.
Yeah, exactly.
Wait, are there headphones in that podcast booth? I
There are.
saw DJ headphones.
It's true. It's true. I find they're always a little hot though, so I decided to use my AirPods.
Yeah.
Yeah. But I was gonna say, yeah, payments is definitely becomes like a very, I don't know, unique place, I guess, that people get really nerdy about. We were talking earlier about that dinner I was at yesterday, and it's just like, yeah, everybody was very clearly had been in the payment space for like a decade or more, and it's like always kind of interesting. Everybody has like a kinship around, I don't know, the unique challenges, I guess, the quirky systems. Yeah.
Did you all hear about was it a 2 day or 3 day ACH outage in Japan back in October?
Oh, did not hear about that.
No one could send ACH for 2 days. Well, I think the six largest banks couldn't send ACH for 2 days. So that's basically everybody.
Good thing I still have my checkbook around.
It works. All right, just doing a quick check to see if we're ready to get started. All right, I think we got the green light. Cool. Well, I think we can't see everybody, but we'll be able to see the chat. Anyways, I think hello everybody. It's good to get started for today. Just as a quick intro, my name is Wayne. I lead our reconciliation product here at Modern Treasury, and I'll play the role of moderator today. And just before we kick things off, I just have a few quick housekeeping items to cover. So first, today's session will be recorded. This recording will be made available to everybody in the coming days. So in case you want to refer back to something, just know that you have that coming soon. And then the second thing is this session is meant to be interactive. And so if you have any questions or comments, feel free to post them in the chat. You should be able to see a couple buttons on the right side of your screen. And we'll be answering questions throughout our talk. And so I'll try to take a look at the question that we're seeing pop up in the chat, and we'll highlight some that are part of the discussion and topical to what we're talking about, just so we keep the discussion flowing. In the event we can't get to your question live, don't worry. We'll be sure to follow up afterwards. So would love to hear from folks who are in the audience today. But yeah, I'm really excited to host today's webinar. We're joined here by two of Modern Treasury's engineering leaders, Matt and James. I think maybe as a quick start, maybe you guys can quickly introduce yourselves. I think it'd be fun to talk about things like how long you've been at Modern Treasury, maybe which team you lead, and also tell us what's your favorite payment rail and why. James, maybe we can start with you.
Yeah. Hey everyone, my name is James Lim. Look after the Foundations Engineering Group, which includes cloud, developer experience, data, and security. I've been here for almost 2.5 years. My favorite payment rail would be either RTP or FedNow, because it is hella cool to be able to instantly verify my bank accounts without having to give someone else my bank password or wait 2 days.
Nice.
That's a
Matt?
good one. My name is Matt McFarland. I lead our payments team. I've been at MT for a while now, coming up on 5 years, so I've gotten to see the product and the team grow a lot in my time here. And I think that I'm just going to go back to the ACH payment rail. I think that there's an incredible amount of depth, and it has been a huge underpinning of the US economy over the last several decades. And there's always more to learn, even after working with the system for several years now.
Yeah, I definitely agree. It's kind of nuts how like some of these systems, they may seem like they're from a long time ago, but they're pretty robust and lots of volume flows through it. And so, yeah, I was going to say, I think we were right before we were starting, we were talking about, even checks still work. So maybe I'll have to pick checks just to throw a wrench in things. Cool. Well, I think we're ready to dive into our content for today. And maybe as a quick intro in terms of what we're talking about, it's definitely a topic that's near and dear to our hearts. So at Modern Treasury, we build infrastructure that helps companies move, track, and reconcile money in real time. And I think in particular, supporting large companies with high volume and high complexity money movement. And so today we're obviously talking about designing for payments for scale. And payments was the first solution that we launched. It's what got us at Modern Treasury started. And because we've seen hundreds of billions of dollars of payments run through the platform, I think we've had definitely unique lessons along the way. And I think, Matt, you've been here, as you said, since almost like the beginning. So you've definitely seen a lot of the evolutions of things. And so today we thought we'd take some time to just share learnings with everybody in terms of what we've seen, what are some approaches that we've taken to build a platform that can support such large volume and such complex payment scenarios. And I think for those who in the audience who are building payment systems at your companies today, maybe you're supporting a new product, maybe you're embedding payments now as part of your platform. And we hope you'll be able to walk away with some ideas for how to anticipate potential challenges you might face as you scale up in volume, or how you even solve that potentially. So hopefully that'll be a good takeaway for you all. So I think the first thing, though, that we should talk about when it comes to scale is just what does it mean to deliver scale with reliability? How do we even think about payments reliability as a concept? I would love to hear from you guys on how do you define reliability as a concept? Maybe James, we can start with you.
Yeah, that's a good question. I can start from the platform perspective. For the platform, I like to break it down into the request-driven part of it, line-driven part of it, and then the storage system. For request-driven, reliability means that the API is available 4 nines or better. Usually that's the current enterprise expectation. It scales quickly when it needs to happen, and it fails gracefully when there are errors or when there's an overwhelming amount of traffic. For pipeline-driven, you want to make sure that your jobs start on time, finish on time, and also you can handle back pressure. I'll be talking a lot about back pressure today, and it's not a massage term. For storage, durability is what I care most about, making sure that the data, once it's there, doesn't get lost. And those are the 3 ways I usually think about platform reliability concerns.
Yeah, that makes a lot of sense. And I feel like a lot of those are just core kind of engineering systems reliability, right? How do you provide that strong foundation for all the systems that sit on top of it? That makes a lot of sense. Matt, given your team focuses specifically on kind of taking those systems and running payments pipelines on top of that, how do you think about reliability?
Yeah, so given that the infrastructure, the foundational primitives, what I was just talking about, are there, I think about one level higher at the application point of view. Payment transmission or origin is just one step of the payment lifecycle. Really, payment lifecycles start when a customer loads a payment order into Modern Treasury, which is our way to represent a distinct payment. We will eventually transmit that payment to the bank. That needs to happen reliably. We need to be able to match that payment to any sort of data that comes back to us from the bank, whether real-time telemetry like trace numbers, returns, or eventually the transaction that correlates to that payment. And then finally, it ends with reconciling, which is a technical term in Modern Treasury's product, matching that payment to that actual money movement, the money that moves out of their bank account. And so for us, the life cycle of a payment can happen overnight, or it can happen over several days. For ACH, you can get returns that come back 60 days late, and that's a key part of managing origination risk in the US. So for us, reliability isn't or at least for me, it's not just did we accept a payment or not, it's was this payment supported from start to finish in a way that allows our customers to be trustful and understand in real time the state of that payment over the duration of time which is relevant for that, how that money moves. So, if I'm doing my job right, customers can spend all of their time and energy focusing on their moat or their differentiation for their product, and they don't have to worry about the details of did this payment succeed or not, and let me know the exact timeline. Modern Treasury will handle that for you.
Yeah. I feel like one insight that I had when we were spending a lot of time, making the platform really robust is we would talk about defining reliability in terms of like customers' perspective, right? So like I think James, you were talking about initially receiving that request, making sure we're here, the platform can receive that request, then following those steps in the payment lifecycle, as Matt, you were talking about, to like, okay, sending the payment, ingesting bank data, and then finally reconciling that. It's like that kind of describes the almost like external customer experience, and we want to be able to measure that and frame reliability in those terms. But then I'm sure like internally within the engineering teams, you look at all the like systems in between, right? Because those are obviously like multiple layers. There's things that are like externally visible, things that are more internal to us. So yeah, it's like lots of different pieces to get right to make sure things are reliable. Are there particular things that you guys think about, when it comes to scale though? Like what are things that make it challenging, I guess, when we're talking about reliability and needing to handle this at large volumes?
Yeah, I can start here. One of the things that is very common in payment systems is spiky load. You run payroll on Fridays, you do monthly close and monthly settlement. It's not unexpected for us to have our largest day in payment volume on one day of the week or one day of the month. And so for us, I work with my teams to proactively schedule load tests and capacity management well and beyond anything that a customer has ever thrown at us or will throw at us in the future. And so for us, I think a lot about peak capacity or peak design. And so for us, being reliable means it's not just everyday reliable. It is on our customers' biggest days of the year reliable, and making sure that that life cycle that I described works even at 10 times or 100 times load what a normal day looks like for us.
Yeah. Reliability, I think, is as many interesting engineering challenges, especially when we have to design systems to handle peak loads, like what Matt was describing. Things that might be as simple as sending webhooks to our customers can get tricky at scale, because it might work at 1 RPS, it might work at 10, but when we start thinking about 5,000 RPS, we are in the territory where it's very easy to overwhelm your customers' webhook listeners. So that means, in addition to enabling retries on those webhooks, we also want to make sure that our webhooks have exponential backoff. We want to make sure that we have ways to queue up and buffer those webhooks and manage that back pressure. Again, that's that word. It's not a massage term. We're managing back pressure in our webhook system, and just being very careful about how we try to send those webhooks to our customers. Yeah,
for sure. Yeah, that makes a lot of sense. I mean, I think we started touching on this a little bit, but I wonder if we can again zoom out. So like now we know reliability, like how to think about it as a problem. We talked about the different components of how to define it, but maybe zooming out from an engineering like systems and architecture perspective, if you can give everybody like a big picture of like what are the major systems that are really important, because I mean, we know that reliability can't be solved by like one design choice or one feature. There's many aspects of it, but I think architectural decisions obviously will change the paradigm with like how you're tackling the problem. And so curious if you guys can touch on a little bit of that, and Matt, maybe you can kick us off here.
Yeah, totally. When I think about simple architecture decisions, I think a lot about how we actually model transmissions to and from our payment providers, the banks. Something that we instantiated from day one at Modern Treasury was a transmission proxy. We call it Relay internally. And Relay has one job, which is manage every bit of data that flows to and from bank servers in a secure and authenticated fashion. That has been an amazing asset that has grown up with us and has become more important over time to enable reliability at scale. This lockdown proxy is also really good, and it has made our security team very happy because it makes their job so much simpler for bounded domain, for where exactly do we need to make sure that every bit transmitted between ourselves and a bank is tightly regulated. For service architecture, like why is Relay so important? If you can give a service a job, and one very simple job, which is make sure data arrives to the bank securely and we get data bank securely, you can define really, really pointed and well-tested strategies for reliability with that, making sure that payment arrives at the bank only once, or making sure that you download data only once, because one of the things that is a real big issue with reliability is if you have more than once guarantees, and that is something that we think about a lot as a failure mode. We do not want more than once, we want at most once.
Yeah,
the relay system. Sorry.
No, go ahead, James. Yeah,
the relay system was definitely a great idea. It's one place to harden, one place to spend a lot of time on security review, and one place to make sure that we have a lot of audit logging and inspection to make sure that it is safe and secured. In addition to the application decisions, design decisions that Matt described, on the platform side, my team has decided to implement the cellular architecture. And what that looks like is each cell is a copy of our entire infrastructure stack. Within that cell, you might still do sharding, but you can think of it as sharding across your entire infrastructure and using the network layer to route requests to individual cells. That way, if there's any kind of infrastructure issue within a cell, only customers that are in that cell are affected. And it is a very effective way to build blast walls between subsets of your customers. Once we have that, we can also have staggered deployments where we deploy changes to one cell at a time. We can do capacity planning on the cell level. We can do linear scaling. If we bring on a large customer, we can just add another cell. And finally, that also allows us to provision dedicated tenancy for customers that want them. Customers that really don't want to have any neighbors.
Yeah. Oh, go ahead, Matt. Were you about to say something?
Yeah. For us, there's one of the primary challenges with reliability is the correctness times performance question. So we really have to understand where it's kind of this perfect trifecta. We have peak volume, we have performance concerns, and then we also need everything to be correct. And actually, one of the best decisions that we made was setting our system up on a transactional database, Postgres. We find that Postgres gives us incredible correctness and throughput if we are using it right. And so the cells architecture has been super amazing for us to hit peak throughput, especially for the load test that my teams runs. We can segregate one database per cell. And that has really allowed us to reach in aggregate or global capacity metrics that would be impossible with just one Postgres database. And that's a really good example of the application logic living together in a great synergy with the foundations that James is describing.
Yeah, that makes a lot of sense. I mean, I think especially in our case, because we're supporting so many different types of customers with different needs, like I think that's so important for us as a platform. I'm even thinking though, like for if companies or teams that are building internally like payment systems for themselves, like you can imagine separating between business lines or separating between different types of use cases. Like imagine you have certain fund flows you happen in real time, right? And so these are like synchronous payment you're sending down to your payment providers versus maybe batch systems. Like you might be able to configure separate systems for different types of performance requirements. Yeah, that makes a lot of sense.
Another decision that we made is that even though we have separate products, ledgers and payments, and they both have ACID requirements, we made a decision to keep everything inside one database so that we can have ledger and payment integrations be ACID as well. What that really means is that we have explicitly made a decision to preserve correctness while maybe giving up some throughput and some performance. We have been deferring any introduction of technologies like DynamoDB or MongoDB or anything that's eventually consistent, and really focusing on mature, boring storage systems, keeping that simple so that the application can be complex, so that our product experience can be rich.
Yeah, James, could you, I guess, like say a little bit more about those types of trade-offs? Like why is eventually consistent, not fit for payments, like as a problem space? And just tell us a little bit more about that.
Yeah, an interesting one, that's pretty simple to describe is a straightforward way to get performance is to put a cache in front of a database, right? And we do that in some places. But Once you have a cache, now you have that data. Maybe it's payments data, maybe it's ledgers data stored in two separate places. And cache invalidation is a hard problem. If your database is updated, but your cache is out of date or somehow invalidated improperly, and your customer makes a read request to that cache and gets that same information, that could mean authorizing a card transaction and there's insufficient funds, or it could mean a payment that was sent again when it shouldn't have been. Those are some of the failure modes that might be acceptable in a different problem space. But when you bring it to payments and ledgering, it is the risks are high enough that we have decided not to take those risks.
Yeah, that makes sense. It's almost like a prioritization of like which kind of guarantees are most important. And I think we touched on how like correctness, not sending duplicates, is like obviously really, really fundamental in payments because it touches money at the end of the day, right? What happens, how the system is processed. Let's see here. It looks like we're getting maybe some customer questions. Audience questions, I mean. Can you share a bit more about how different customers may interpret the notion of reliability in different ways? Is it different depending on the type of customer?
Yeah, I'd love to take this one. So I work with a lot of customers across a lot of different verticals, and I will tell you that someone running a wallet application on a Modern Treasury interprets reliability than someone who runs payroll with Modern Treasury. So a lot of it comes down to understanding the business and the business use case, and specifically what rules or requirements are subject to each business. So we've been talking a lot about payments, but Modern Treasury also handles inbound payments. And for customers, that can be the left hand to the right hand, which is nation. So the way that we think about reliability, reliability means a lot for sending a payment, but it also means giving customers timely and especially accurate information for inbound payments. So we have a virtual accounts product which helps customers attribute payments that are received to unique parties to help them understand who sent the payment. That is a reconciliation problem. You want to understand when the money lands in your account, and we want to give our customers as much information as they can to make an appropriate business decision for them. We talk a lot about seasoning payments in the ACH system. Seasoning isn't as relevant for payments that are received by wire if you're funding a wallet from overseas, for example. And so the way that we handle this is by giving as much accurate information to our customers as we possibly can. And that means that we also spend a lot of time working with the underlying bank and payment providers to fully understand part of their specification. So going back to something you were asking earlier, Wayne, talking about architecture, you can sit there and you can try and build an ideal architecture in a vacuum, but ultimately, if you're going to be going into payments and you need payments to be reliable, which you should if you're going into payments, you have to understand the actual payment specifications. You really have to go deep on the rails. You have to understand how the network providers interact with each other, and there's no substitute for that. And Modern Treasury has been a good partner for our customers, and we will always be a good partner for our customers. And being that expert who has seen payments applied across verticals and across businesses at that end.
Yeah, I feel like, listening to you talk about that, one thought I have is a lot of the differences in reliability, I feel like manifests in the differences in rails, right? So how you think about how RTP or FedNow might need to behave is very different than ACH. What are the types of exceptions that can crop up, the timings of things. So I think a lot of the complexity comes in even just like the payment rails that you're going to be using as a product to support your end use case. Like that is like where it manifests in different ways to think about reliability. And then you kind of, if you're then using potentially multiple banks or potentially multiple payment providers, that then like multiplies that complexity, I guess.
Exactly.
So, all right, seeing some questions being here. Let's see here. We got a question from Matthew asking about whether or not we store data payloads. It's kind of sent and received by relay, or on a smaller scale, the banks ask us to record and share the entire API request. We send when something goes wrong before their support teams agree to investigate it. Does that principle apply for Modern Treasury as well?
Yeah, I can answer that question. That is one of the design benefits of having a bank proxy. So in that one proxy layer, we can log the requests and responses. So we reject them, we take out all the authorization headers, put them in S3, it's a privileged bucket, And internally, we have a process where someone can say the reason to say, hey, this is why I need access to this data, and then we can use that for troubleshooting. Great question. Thank you, Matthew.
Yeah. We'll go from, oh, Matt, you were going to say something?
Yeah, and I think I saw another question asking around duplicates. Having programmatic access to the entire history of a customer's interactions with the bank proxied through Modern Treasury is incredibly valuable, because there are times where our bank server changes, resulting in unexpected changes to the actual data stream. And so when we can be a source of truth and look at every transaction and every payment, we can offer higher reliability to say like, oh, something is unexpected here, which is really part of our anomaly detection system. And we can proactively alert our customers to say, we are not going to let the payment go through. We actually think this is a duplicate due to some unexpected error in the entire chain. And that has been a really valuable tool for offering a higher level of reliability to our customers.
Yeah. There's another question here from James that's in the audience. That's I think an interesting one. It's talking about separate teams, right? So let me just read it first. It says, you talked about your separate teams and reliability. How does the interaction between your teams impact the reliability of your payments products? So, for example, if platform is not available or payments platform is not available, what is your approach to this problem? I think it kind of touches on not just like the system side of things, but potentially like team coordination, systems coordination. Yeah, Matt or James, I don't know if you guys want to comment on that one. I think it's an interesting question.
Yeah, that's an interesting question. I'm going to start first. I generally apply the SRE approach, defining service level indicators and service level objectives to different layers of the stack. And these SLIs, once you have defined them, are kind of like guarantees that you provide to internal stakeholders and to external stakeholders. So, for example, the API needs to be up 4 nines. GraphQL has some number of nines defined. We define the probability or the percentage of jobs that are allowed to be interrupted if they are already started. And we have more examples of those. So we use those internally to hold ourselves accountable to a certain degree of quality. And that is the baseline for team coordination. If any team who's responsible for a certain system is not their objectives, their SLOs, then that triggers triage, improvement, fixing, debugging, and that's how I think about it. Matt, your final thoughts.
Yeah, and I can help James's team build that roadmap, because what I can do is specify, okay, across all customers, this is what requirements the system actually has. Let's talk about peak capacity. Let's talk about latency, or how long jobs can sit in queues. And that has been a really effective way for our two teams to act on a hinge point or an interface point around building a reliable product at an application level and at a functions level.
Yeah, James, I'm curious if that answers your question. Happy to take follow-ups.
Yeah, for sure. Yeah, one thing I was going to say about the kind of SLIs, SLOs that you were mentioning there, James, is like it's almost like a translation, right? Because ultimately we need to say like, well, what does the end payments need to, like, how does it need to behave for customers? Like, how are they using, again, different rails? And then how do we then translate those into internal system requirements? And then it's the interlocking between upstream and downstream systems of understanding like, okay, if Relay needs to send this many requests, what does that mean for the underlying like queue processing speed and things like that?
Exactly.
So yeah, it's definitely an interesting one.
Yeah, along different dimensions, you can kind of think of it as a budget that you start with, and you allocate that budget across the different layers.
Yeah, exactly. Okay, we'll take one final audience question right now around this topic before we keep going. But Theo asked, how did Modern Treasury's payments product evolve over time? Did we have to rebuild it over time? I think, talking about like the underlying systems, and how important was it to get architecture decisions right from the beginning?
Yeah, absolutely. I'd love to talk about this one because I've been there for most of the evolution, which has been really fun. Yeah. Modern Treasury started with a really simple premise, which is be very good at transmission of file-based systems. And that really comes out of the founders' experience at their last company running an internal version of Modern Treasury that ran about $1 billion a month as part of mortgage servicing. So when I joined, one of those projects was actually, hey, Matt, go work and augment Relay so it can handle HTTP requests to power the RTP product. RTP is generally always available as an API-based system for banking products, and that's something I've seen come online over time, and that's how FedNow is being designed today. So Relay, which was a file-based proxy, also turned into an API proxy. And that was a huge step function change that largely we've handled by thinking about the same fundamental principles that powered files. Platform, or the monolith, generates a data blob that represents everything that is unique about a payment. And in this case, instead of a not a file or a Fedwire file, it's a JSON payload. And it transmits that through Relay, and Relay transmits that request to the bank. And the data comes back in the same form. And I do think there's one interesting architectural evolution here, which is the monolith needs to be able to handle a real-time response, different HTTP error codes or timeouts, for example. And that has been a large shift in how our application has had to handle errors or map over the entirety of responses. So files are fundamentally asynchronous. The API is fundamentally synchronous. And so that has been an interesting change for our architecture, because for API requests, it's the error handling, but it's also handling webhooks. And so you can suddenly have a huge amount of data that a bank is pushing to you in the form of webhooks that you have to handle scalably. And I would say that the best takeaway has been, don't think of these as disparate systems. Think of them as the same system. Instead of reading responses from HTTP, just think about them as reading a file that's JSON. And that has been a principle that scales for correctness and fault tolerance, because then we can actually start thinking in an asynchronous way, which scales a lot better for us.
Yeah, for sure. And I mean, I feel like, the question around like, how important is it to get it right the first time? I mean, I suppose these decisions are like harder to change, right? As you're supporting, as you have like an online system that is supporting a lot of volume. And so I think part of today's talk is even just like sharing our learning so that, hopefully you can get it right earlier on. And I think we definitely benefit a lot from some of these key decisions up front.
Yeah. Also, our bank partners have been improving their APIs and integrations over time. So for example, if one of our bank partners adds support for idempotency headers, we would add support for that as well and pass along our customers' idempotency keys to the bank, just to get that greater protection.
Yeah, idempotency is, we could spend 2 hours just talking about idempotency alone, but one of the design principles that has been successful at Modern Treasury is building idempotency within our systems. So you can take advantage of your Relay proxy by building idempotency between your services. So everything that we build at Modern Treasury is idempotent. All the jobs in the monolith are idempotent. Everything in transfer through Relay is idempotent. And so we guard against errors or faults from propagating from one system to another, eventually all the way to the bank, because that's a truly disastrous failure mode. And we stop that by building proactive safeguards or layers of security and fault tolerance all the way through our system. And that has been an extremely important design principle to empower reliable payments.
Yeah, makes sense. Cool. Yeah, hopefully that answers that question. Definitely keep the questions flowing. But I did want to talk, I think we started talking about this a little bit in terms of the trade-offs and maybe like the potential dangerous failure modes in payments. I did want to kind of touch on this topic because I'm sure it's for a lot of folks in the audience. And, when I think about payments as a problem space or as a system that we need to build, and especially from a product owner's perspective, I think oftentimes what I think about is, well, how do I work backwards from that consumer experience, right? And I think that's a lot of the approaches that our customers will take, and especially the product owners that we talk to there is like, okay, yeah, like we want to support as a business multiple pay-in methods, multiple payout methods, so there's flexibility involved, there's faster payments, but obviously places a higher load or higher burden in terms of engineering to design those systems. And so I'm curious if you guys can particularly talk about like trade-offs that you guys have to think through when it comes to payment systems. I think we started talking about some of those earlier around like correctness and throughput and things like that. But yeah, just curious if you guys can delve in a little bit more on that topic.
Yeah, I will say that there are better payment rails suited for certain kinds of applications. And the way that I've seen that play out is working with customers and their banks to actually come to decisions around which of the banking products suitable for this customer. So for example, running hundreds of thousands of payments a day on a daily volume is a great use for a Nacha file, but is not such a good use case for real-time polling and bank APIs. something like a real-time payment is a great use case for the API systems. And you could imagine that that conclusion falls out of the load or capacity that these systems can support. ACH does trillions of dollars a year. It's tried and true at the hundreds of thousands or millions of payments a day for customers around the country. Where I think the secret sauce is working with the bank and the customer to understand the business requirements and translate that into the right choice of technology. And that is not something that I can build a recipe book around. It's a more in-depth conversation. So going back to the use case, real-time notification for funds received is so incredibly important, and you have to choose the right product and the right kind of integration with Modern Treasury to support that. So you're going to be ingesting webhooks. We're going to make sure that we're pulling on a frequent case with the bank and all that good stuff. And then at the other end of the spectrum, someone who is running hundreds of thousands of payments a day, like, yeah, I want to be prepared for that in a file-based approach, and then we'll revisit the implementation as the demand grows.
Yeah, I wanted to pull out one kind of thing you were talking about there, Matt, because it reminds me of a conversation. Like, we were at this summit meeting yesterday with one of our major bank partners, right? We were talking to like their product people and like the people who understand their systems. And this point that you're making around payment rail. So like you first have to pick the payment rail that suits, right? Like let's say you want to just offer the flexibility of doing ACH. Okay, great. But the bank oftentimes will offer multiple ways to send ACH payments, right? So they might actually even accept ACH via API or via file. But I think what's maybe not immediately apparent when you're looking at it outside in is like, well, actually internally at the bank, there's like two different systems there that actually supports it. And maybe it's even more than two sometimes to people's surprise. And so you have to really get into the details of like, okay, well, what's the shape of the payment? What's the peak load? What's the average load? And, you know, what's the, how fast you need to be able to send a request before the cutoff time, let's say. And this is exactly what the bank partners were saying as well. Like they oftentimes want to go to that level of requirements understanding because then they can help you pick the best choice in terms of like, are you connecting to them via API? Are you connecting to them via files? And I just thought that that was like really interesting and something that's maybe like unintuitive when you look at it naively as a system.
Yeah. Having a partner who can help you navigate those conversations and tell you about all the intricacies of the bank definitely helps. On the platform side, one trade-off I think about a lot is how do I balance development velocity with reliability and correctness? And you know, your engineers, they want to deploy every day. They want to get feedback from the production system every day so they can learn about bugs and fix them really quickly, right? But for reliability, we often want changes, especially risky changes, to have a little bit of an incubation time so that they can bake and we can learn about the bugs in a relatively low risk way. So what we've done with the cellular architecture is to introduce staggered deploys, where high risk changes can sit on earlier cells, which might just be smaller customers or internal customers, and give the engineer the feedback that they need to continue improving the system before rolling it out to our enterprise customers.
Yeah, I think that makes sense. It's some of these like engineering best practices that also are really important in developing the systems. I think that's a great point. Okay, we got a couple questions relating to this. Umar is asking, you mentioned processing transactions async for eventual consistency. How does that improve performance without delaying for too long? So I think, again, it's kind of like this speed of response versus like the load that we potentially have to handle, I think.
Yeah, I can talk about that for especially handling peak transaction volume. So in the life cycle of payments, we send a payment and eventually a transaction comes back to us. The money has moved. And that is our best signal for the truth of the matter, which is if the money is moved, the payment ultimately has been accepted. And then internally, what happens is we think about it as there's a certain amount of budget, there's a certain amount of minutes before that transaction becomes overdue for a reconciliation state. So as soon as we import that transaction, it becomes material. So a transaction created webhook, for example, gets sent to our customers. Then we start to that up and we start to do the reconciliation matching. Which Wayne is an expert at because that's sort of the product that he manages.
Yeah.
And for us, it's all about it's importing that transaction, making sure that it's stored and unique in our database, moving on to the reconciliation stage before our budget is exhausted. And that's what it means to offer a real-time performance system. And so that's a very like payments transaction. We also have transactions in our ledger product. James, do you want to speak to that?
Yeah, I can talk about that. But before that, I just want to point out that being able to process these payments asynchronously also allows us an opportunity to learn about rate limits and bottlenecks at the bank side. So sometimes they might throttle you, they might rate limit you. And having a way to accumulate all of that back pressure so that we can send it to the bank at the right time without failing the entire batch of payments helps improve both performance and reliability in this case, actually.
Yeah.
Yeah.
Yeah, no,
Go
that
ahead.
makes sense. No, I think one thing that you were saying there, James, that was making me think about is like, and to connect it to Mara's question, it's like, it's almost like the question of how do you define what it means to delay too long, right? And I think part of it is like James, you were saying on the bank side, like what's their rate limit? Sometimes that's not published publicly, and so you have to think about like, well, okay, well, how much time do you need to be able to like how fast do you need to process things in to like make sure you can get in within cutoff or overwhelm the banking system for your banking partner. And then on the other side, it's like, again, from the customer's perspective, it's like being rigorous. Like, I think that was the insight for me on a product side. It's like, okay, how do we make sure we can define that like speed really critically? Like, okay, somebody's trying to send 1 million payments a day, but what does that actually mean, right? Because that ultimately needs to translate to, for a given cutoff window, like how soon do we need to process things? And so I think being specific about what too long means is ultimately what's going to be helpful here.
Yeah. And talking about the Ledger's product port just for a second there, we noticed that there are a lot of customer use cases that always need to debit or at least check a shared cash account. So that's what we call the hot account. And one way to improve throughput is to allow some of those transaction process against that hot account to be asynchronous. If we understand that that use case can accept a certain degree of eventual consistency.
Yeah, makes sense. Crystal asked another question that's around the bank connection. So she said, for self-managed bank connection, how do you ensure data reliability if the banks provide data in a more manual way? How do you work with banks to ensure that the data is sent in a reliable format? That's a great one. Matt, you want to take it?
I've got a lot of stories around this one. But we actually do a lot of validation. One of the benefits of Modern Treasury's business is we work with a lot of banks. It's over 30 banks at this point, and even within a bank, it's more than one of the product interfaces within the bank. So when we think about reporting data, I think about ISO data, I think about BI2 data, I think about bank APIs, and across all of that, we've learned that there's a certain variation that especially bank transactions are represented. I see that Crystal's working on Treasury, so we're probably talking about bank transactions here. So we know exactly what we need. Every transaction needs to have a certain amount and needs to have currency, needs to belong to an account. And then there are some options that we can configure or we can interpret from its context. So is it an intraday transaction or a posted transaction? And if we really don't have enough information to make a recognizable transaction to store in our database and tell to the customer, we actually have a 24/7 on-call that works to triage those kinds of issues, and then we work with the bank to understand and mitigate that. And what that means is we end up with a system that learns and is resilient to failures over time. Because we see one anomaly, then we build redundancy to that in our system today, and all of our customers take advantage of that. We actually have a new product that we're offering to help power the reconciliation use case, which is customers can bring BI2 files that they download from the bank, or they can post transaction data manually. And those same validations that we're learning from the core system or the core use case for a managed connection, our customers in those bring your own data use cases can take advantage of as well.
Yeah, I think fundamentally, like what's tricky here is that BI2 ultimately is a spec, but it's not necessarily it's followed religiously, right, bank to bank. And so I think to your point, Matt, it's like the system has to be resilient. Or it's like sometimes needing to infer, like, okay, what's this actual? It's like this bank is using a code that's non-standard. We have to like learn to decipher what that means, and so that the system can be resilient to that. The other question here was also around how do you work with banks to ensure the data set is reliable format. I think to a certain extent, it's like, yeah, you need to, I think, dig in a lot and provide examples of inconsistencies that you've seen and try to find out. I think part of it is like learning how to translate the bank language, I guess is what I'm trying to say. It's like with some of our bank partners, we've had to learn like, okay, you guys called this file by this name. Okay, this is what gets us the data that looks like this. And, that's what we backwards, if you will, from like the data points that you need for things like reconciliation, so that ultimately trace back to, making sure that you have the right reporting, I guess, turned on at the bank. Theo jumped in here with a question. James, could you please repeat the term you mentioned to explain how the features are deployed to specific low-risk customers first?
Yeah, the architectural pattern is called cells, CELLS. There's a paper on GitHub. AWS uses it to build S3, and several SS companies have adopted that pattern as well. A cell is a copy of infrastructure. You can deploy tenants into a cell. Tenants don't cross cells. And once you have, 3 or more cells within your infrastructure, you can kind of design a deploy pipeline and pick which ones to deploy to first and how long that new build version stays in that cell before moving to the next one. You can run smoke tests against it. You can wait for errors. You can get creative. And once your deploy has reached, the first 2 cells, your engineering team has enough feedback and observability to know to know if they can continue or if they need to go back and wait.
I'd like to jump in there and talk just on the smoke test part. One of the things that has been a really great product initiative between Foundations and my team have been building what is essentially it's like a smoke test integration test. So we have an API client who mimics the customer on one side of the CI pipeline, and then what we call smoke, it's a fake bank on the other side, and it integration tests the entirety of the API surface. So creating a payment order, watching that payment get sent to the fake bank, which is actually just an S3 bucket under the hood. The fake code ends up taking that fake payment and turning it into a new transaction for that system to ingest and eventually get all the way back to the customer or the initiating side as a payment that completes and gets matched to a transaction. And that gives us so much confidence that every deploy we put to the system succeeds, or if it will not, we stop it before it ever progresses to the first customer. And that is a remarkable system, taking advantage of both the testing infrastructure that we have on every deploy and the cellification concepts.
Yeah, to add on to the example that Matt just gave, I think one reason why this architecture is a lot better than just staging is because in addition to those smoke tests, you could also just run a penny test if you want to. For example, if some engineering team knows that they are changing their serialization format for JPMC, we could deploy that to US 0 first, do a penny test before going to US 1. And real live connections to a bank is probably something you're not comfortable enabling on a staging environment, but in production, that's a no-brainer.
Yeah, I feel like you guys are kind of already hinting at this, but one of the other questions I was going to ask was around the scariest failure modes and kind of preferred ways to handle that, right? Because I think what you guys are talking about here is like preventing, like you'd rather go slower to prevent some of these things from propagating, right, into the system sometimes. And so, yeah, curious if you guys can add to that in terms of, what are the kind of worst case people should be keeping in mind and being on the lookout for to prevent and how to gracefully handle those situations.
Yeah, I'll talk about 2 very specific failure modes. So at a transmission layer, it can become ambiguous what the state of a payment is if you end up with a connection error. So let's say you're transmitting a file. If that file connection upload is interrupted at some layer between you and the bank server, or same problem but applied to an API request, it is very difficult for you to ascertain with great certainty what is the status of the data. Is it accepted on the server side, or has it not been accepted and I need to re-upload? And there's a few ways that we deal with a very fundamental problem at Modern Treasury. I mentioned idempotency, like we bake idempotency into the stack at every layer, but we also work with bank partners to actually support inquiry methods where we can understand the status, like has this payment been accepted or not? And we have really careful handling for payments in this interstitial state. We sort of call it a purgatory. We either know fully that it's succeeded or fully that it's failed, so that we can make the correct decision in real time for the customer in these situations. I mentioned something earlier, which is when money moves, that's the ultimate sign of success. That is one of the most fundamental observability principles that we can build smart systems around. So for us, we do all sorts of alerting and detection based on when do we see transactions, or when transactions that look suspiciously like other transactions? There's actually some really great product that we have around notifying customers for duplicate payments that might have been run off platform. And that is something that we build off of the actual money movement streams that we're observing directly from the bank. So those are like a couple of ways that I handle scary situations: is move very carefully, do not risk a double send or a duplicate ingestion problem.
Yeah, and I think even like to build on that, from the reconciliation standpoint, I think that's why Modern Treasury to start, and I think this is what we recommend any payment system do, right? Is like, it's not just about sending payments, but it's about like when you have to send payments, you have to reconcile them, because that's the only way for you to confirm ultimately from the bank. It's like, because that's like what's like the bank will stand behind too, right? It's like what's on the bank statements that describes what actually happened. So it becomes both a sending, like an origination problem, and a reconciliation problem. Sorry, James, you were about to say something.
Oh, I was going to talk about my series.
Yeah, go for it. Yeah.
Yeah. What's scary for me for platform is having a platform failover on the most important days for our customers. Maybe one of our customers is having a major trading day. Some meme stock just popped, or one of our customers, deducting payroll every Friday. Like if you miss payroll, it's a big deal. Or some of our customers launching a new mortgage product and then suddenly having a large amount of debits on a big month. If the traffic patterns were organic, meaning they rise naturally throughout the course of the day and then die down throughout the night, it's very easy to build in auto scaling, and that is like a well understood thing in the industry. But for very spiky, chunky, less predictable patterns, we need to preemptively either working closely with the customer or looking at the traffic patterns in like past months and trying to get ahead of that. One thing we also do is we try to make sure that with the SLIs that we have, we should make sure that every layer has about 2x headroom above the known or stated customer volumes, just to make sure that if a customer is having like a sudden unexpected big day, we have enough room to run, someone gets paged, and then we can quickly make adjustments when necessary.
Yeah, I think the idea of like proactively building headroom is like what makes it a problem that we can solve in advance, right? And not something that we are, yeah. And I think this is, again, just totally applicable for folks who are building their own payment systems too. Just think about like the headroom that you potentially need based on your business's patterns or your product's patterns. We got a related question from Alex around like being proactive to different issues. Let me read it here. It says, when working with multiple entities, you end up with multiple ways to say something that mean the same thing. I think in particular, one that comes to mind for me is banks. Obviously, banks will say things, different things in the same, or same things in different ways. So you map this at the beginning, but new variants that you didn't consider always comes up. How do you deal with this in production? Are you reactive to these potential variations?
Yeah, I see this a lot when it comes to the variety of data that we'll actually receive from banks around incoming payments and the transactions that result from there. And the way that the team has evolved the technology has been really great. Usually it's not that the entire batch of information is problematic. There's usually one problematic record. So what we've done is implemented technologies to segregate that one problematic record that we're not sure how to interpret or we've never seen before, while allowing the rest of the report to succeed and complete that payment lifecycle. And usually what we do with problematic records is we do have to have a conversation with the bank. For anyone who is going on this journey internally, like, you will have to build an edge case around a teller entered transaction eventually, something that a human creates. It's not according to spec, and it will confuse you because what you have to do in that situation is you have to literally call the bank and understand what happened here, and then they will usually investigate and get back to you in short order. But that takes hours to react to, and so what you want to do is make sure that the things you are reacting to are small in scope and isolated. And you want to let the things that you do understand or that you can be proactive about to happen out of band with human intervention. There's always going to be a human for the edge case, and that is appropriate. But for the common case, or the cases that you do understand, you want your systems to be able to make progress on.
And I think that's like a great way to highlight like how we handle the tensions between, again, like speed of processing, right, and especially at the large volume, versus doing safely, right? Because ultimately, I think it goes back to this idea of like you don't want to accidentally infer or interpret something as having been complete or even failed. Like, okay, we haven't seen this failure mode before. We assume the payment has been stopped. So then you end up causing the system to send that same payment again. Be very, very careful with those kind of scenarios of unknowns. So we can't. So I guess, yeah, Alex, getting back to your question, it's like, yeah, there are some cases where you have to be reactive and involve a human in the loop to confirm and to get to additional certainty. Yeah.
Yeah, I'll plug Wayne's product here. Definitely build reconciliation so you can compare the bank's records with your own.
Yeah. No, it's just such a critical concept. All right. I know I'm just being mindful of time here. I know we got a couple minutes left. I guess maybe finally, let's talk about maybe general advice that you guys would like to offer. I mean, I'm just thinking about, our audience that might be other engineering leaders or product leaders that are on their journey of building a payments product at their company, or maybe are seeking to improve their systems so they can handle scale. I'm curious if you guys have any final advice that you'd offer.
Yeah, I think I've got points that I failed to mention earlier around architectural decisions is related to data modeling. So payments are complicated entities. There are probably over 100 fields that can be described or used to describe a singular payment, from all the batch information around the originator, who you're trying to send the payment to, ultimate beneficiaries, ultimate recipients. And the best way to deal with correctness in that space is to have a really strong data model for all the payments that your business can expect to originate or receive at any point in time. And to do that, you're going to have to go back. You are going to have to go read the notch manual. You are going to have to go read the ISO specification. You really do need to understand all the core payments. But if your data model for a payment is detailed and strong enough, you'll be able to power higher performance throughput while also having higher levels of correctness. James mentioned that cache invalidation is a really hard problem. If you don't successfully denormalize all your data and make sure that everything is up to date, it can also be really difficult to reason about how different related entities get pulled into a specific payment. So something I see a lot is beneficiaries updating their external accounts, which is really just their bank accounts that you can send payments to. You need to have a strong audit record internally around how that information gets changed and can affect payments that have been sent, payments that are queued up to be sent, and have strong approvals around that kind of information internally.
Yeah, that makes a lot of sense. James, any advice that you'd give our audience?
Yeah, I have two. First one, again, is recon. So your internal system of record, which is what they expect to happen, and then you have the bank system of record, which is what actually happened. Definitely compare those. That is the ultimate way to find out if anything happened or anything went wrong. And the second is track banking holidays. They do change. For example, Juneteenth is now a holiday. And if you're working with international banks, they have their own holidays. Definitely make sure that you take that into account.
Yeah. Yeah, I think these are great points, guys. I almost feel like the summarizing theme here is you have to build systems that anticipate change, right? And kind of build defensive systems. And so like, how do you, I guess, get ahead of that and be proactive to that just because of the complexity that's inherent in this space. So yeah, I think that's great advice. Thanks, guys. I think one final thing that we want to leave everybody with, just parting, if we can go to the final slide. This is more just if you want to find out more, I guess, learn more about payments or come talk to us. Modern Treasury is hosting a event. This is our event called Transfer. It's happening Wednesday, May 15th, and it'll be both in-person and virtual. So the in-person piece is in San Francisco. And so I think Jana on our team is posting in chat here. There's a link involved. So if you're interested in registering, you can click on that link. It's where you can come talk to us to learn a lot more about payment systems. And so, yeah, we hope you enjoyed the session today. And thank you for taking the time to spend that with us, talk about payments. Thanks, folks.
Thanks, everyone. It's been great.
Thanks.